Rajiv, are we good to start?
We're good to go. So over to you and Prashant. Thank you.
Yeah, thank you. Good evening, good afternoon, good morning, depending on where you are. My name is Subhash Mandal, and I would like to welcome you to this seminar titled Communication Research and Research Mindset. And this event is jointly organized by IEEE Communications Society Bangalore, IEEE Communications Society Delhi, ACM India, and Indian National Academy of Engineering. The event starts with a talk by Dr. Swarun Kumar titled Toward City Scale Low Power Wireless Internet, followed by a panel discussion on research mindset moderated by Dr. Aloknath. With that background, I would like to request Prashant Chug, Chair of ComSoc Delhi, to say a few words before he hands over the session to Dr. Rajiv to introduce Swarun and take it forward from there. Thank you.
Yeah,
Prashant?
thanks, Subhash. Thank you, Subhash. So it is a very nice that four different organizations are collaborating to welcome Dr. Swarun. So I just look forward to this opportunity, and I look forward to collaboration opportunities among the organizations to have distinguished speakers in future also. I thank Dr. Rajiv very much for inviting Dr. Swarun. So not taking much time, we look forward to Dr. Swarun's talk. So I hand over to Dr. Rajiv to introduce Dr. Swarun.
Thank you, Prashant. Thank you, Subhash. Great pleasure to be a part of this joint seminar under the aegis of IEEE ComSoc Bangalore chapter, Delhi chapter, ACM India Council, and INAE. It's a great pleasure and a privilege for me to introduce a very dynamic researcher in the area of communication networks, Swarun Kumar, whom I happen to know for many years now. Swarun really needs no introduction in the world of communication networks, whether it's wireless networks or whether it's wired networks, and the list goes on and on and on. But in order to be fair to the audience, I would be delighted to introduce Swarun Kumar. I'll take a minute to introduce Dr. Swarun Kumar. Dr. Swarun Kumar is an assistant professor at Carnegie Mellon University, where he heads the Laboratory for Emerging Wireless Technologies, the YTech Lab. Swarun designs and builds novel systems to enable faster wireless networks and new services. Swarun has received the Best Paper or the Best Demo awards in several conferences. He has widely published in several reputed ACM and IEEE journals and conferences in diverse areas such as TV white spaces, millimeter wave communications, low power WANs, low power IoT, full duplex radios, the next generation cellular networks, and the list goes on and on. Swarun is a recipient of the NSF Career Award and the Google Faculty Research Award. Swarun received the George Sprouse Award for the best PhD thesis in computer science at MIT and the President of India Gold Medal from IIT Madras. So now request Swarun Kumar to share his thoughts and deliver the distinguished lecture titled Towards City Scale Low Power Wireless Internet. Thank you, and over to Swarun Kumar.
Thank you so much, Raji, for the very kind introduction. Thank you all for joining. Thank you to the organizers for welcoming me for this seminar titled City Scale Low Power Wireless Internet of Things. Raji already introduced me. I'm from Carnegie Mellon. It's a pleasure to be hosted by you all, and I look forward to the interactions and the discussion later after the talk as well. So I'm going to start because tomorrow we have the next IPL season sort of starting. I thought I should start with a picture from a previous IPL, and you know, I'm not going to talk about the game. Don't worry, but I wanted to sort of make you focus on the background of this picture, which is something you see at concerts, something you see at cricket games and other matches and other events of the like. And you sometimes see these people waving phones, an ingenious way of showing their support for when their favorite team is ahead or they're enjoying the concert. But I don't want to focus on the ingenuity of the crowd here for the moment. I just want to take a step back and wonder that, hey, this event was held about a year or two ago. And we have so many phones, so many mobile phones in the crowd in India. And about a couple of years ago, India has India sort of crossed a very important threshold, which is there are more mobile phones in India than there are people in India. That's amazing. More than a 1.2 or 1.3 billion phones at this point, I'm sure. And this is remarkable. And India has literally propelled the world itself, being a large and populous country, to cross the same benchmark as well. There are more phones than people in the world as of 2018 or so. And this is remarkable. This is amazing. And as a wireless networking researcher, which is where I was coming from, this made me proud that, hey, our community has achieved a remarkable milestone in making the world more connected. But also, this was around the time when I was starting my career at Carnegie Mellon doing wireless research. And I thought to myself, okay, now that we've connected everybody, what's left to do? If we look at a stadium about 10 years in the future, what will this picture look like? What are the new things we can connect if you've connected all the people already? And this led me to the next frontier, which is all the billions and billions and billions of objects that people in the stadium are carrying. Why should we stop with connecting 7 odd billion phones in the world? Right? Let's go further. Let's connect smart headphones. Let's connect notebooks. Let's connect watches. Let's connect shoes. The pavements, the roads, you name it. Right? Why don't we connect everything else around us in the world? And what would that look like? And what are the interesting applications that would enable? And this really led to my research trajectory in the subsequent years, which is asking the challenging question, which is, how do we even design a wireless network for everyday objects, for the so-called vision of the Internet of Things, right? Connected everything around us. And second, if such a wireless network exists, what can we do with it? Like, what can we use this network for? What can we learn about ourselves? What can we learn about the environment? What are the interesting services that we can build on top? And so my research has spanned all of these different topics that Raji mentioned: low power WANs, 5G cellular, faster LANs on the challenge side, as well as interesting opportunities on body tracking, health tracking, location awareness, and security applications on the opportunity side. But for today, I really wanted to focus on two specific topics. One is low power wide area networking for connectivity. And the second is some of the opportunities from building a shape aware world. And I'll first start with connectivity challenge, which is, how do we build a low power wide area network that connects everyday objects like what I showed you in a couple of slides ago? So let's sort of do the following thought experiment, which is quite similar to the thought experiment that I did when I started my career at Carnegie Mellon, which is, okay, I want to connect everything in that stadium. What is the quickest and easiest way to do that, right? Everything, like shoes, wallets, you name it, clothes, right? So I added a sort of a laundry list of requirements. Now, the first requirement, I'm sure you all agree with me, it has to be, the technology has to be wireless, A, because I do wireless research, and B, because you don't want wires dangling from your t-shirts and shoes, I'm sure. And second requirement, and I'm sure you empathize with that as well, you don't want to charge everything around you every day, just like you charge your phones. I can't imagine plugging my shoes into the wall every day. Now, here's the third requirement, and this is the requirement where I sense some disagreement sometimes, but this is an important requirement as well, which is your devices, the objects that you connect to the internet, must be able to talk to base stations several tens of miles or kilometers away. And this is particularly important in making these networks accessible. Remember, one of my requirements in the talk is that we want to connect everything to the internet in the quickest possible way, in the fastest possible way, which means we don't want to deploy too much infrastructure. We want, in a matter of years, for the whole world to be connected to the internet, all the objects in the world to be connected to the internet. So we don't want to deploy a base station in every home, in every street corner. We want to be able to deploy the minimal infrastructure possible to connect everything. And now, if you look at all of these requirements coupled together, it's quite evident that the wireless technologies we take for granted today don't quite fit the bill. Wi-Fi, cellular are not particularly energy cheap. They require charging every day. And other technologies like Bluetooth do not fit the bill for talking to base stations several miles away. And so this exploration led me to sort of model what would be our ideal world. So let's take some object we care about, alarm clock here. Could we, in principle, attach to it a very, very cheap radio interface, a very cheap chip of some sort? And then if you remember, if you like me are wearing a non-smart watch, right, which is, which has this very familiar coin-sized lithium-ion battery that, like the one I've showed there, could you patch a bunch of these together and get a 10-year battery life to connect your alarm clock to the internet? When I say to the internet, to a base station potentially several miles away. What does it take to build a cellular network that operates on a watch battery that lasts 10 years? And this led to a broader exploration of research that's been out there in terms of technical innovation of late. An entire field called low power wide area networks, or low power WANs. So if you've heard of technologies like Lora, Sigfox, and the like, they attempt to do some version of this, right? But we took a step back and we actually evaluated some of these commercial technologies. So we went ahead and built what was at the time the largest experimental low power WAN deployment from a university that was led by a university in the US. And we set up in Pittsburgh a whole bunch of these base stations deployed on rooftops around the campus and in other areas of Pittsburgh. And we deployed some of these gateways indoors, many of the gateways outdoors on rooftops as well. And we were hoping in principle that, hey, this is supposed to have a very huge range. So let's get coverage of the whole city, right, with our deployment. But it's not quite what we were looking for. I mean, there was some coverage with lots of base stations on the order of few miles, but not quite the span that we were looking for. And lots of isolation, lots of islands of coverage. And actually the killer was that it was, remember, and if you've ever watched National Geographic and you've seen all of these animals wandering around with all of these radio tags to track their location where they're moving around, technology to connect devices, battery powered devices from long range has existed for a while in that context. Believe me, nobody's charging and recharging a lion every day or a radio chip attached to a lion every day. So this technology has existed for a while, but it really works in open field, right? In the savannas, right? Where you can set up a tower in a mountain and you have direct line of sight connectivity. But the moment you move from the rural, and open sort of landscape forested environment to the urban jungle, which is buildings, tall buildings, and multiple floors, the situation in the wireless environment is totally different. So here, this is sort of an extreme example where we have a gateway that's right at the top of the roof, and you see different levels of battery life experienced by all the different sensors that we've deployed at various floors in this building. And as you can imagine, the closer you get to the bottom, the worse your performance in terms of battery life for these systems. You're not getting the 10-year battery that you desire. You're also not getting the range that you expect from these systems. So the most important metric, I mean, I know when we think wireless, like we want speed, we want gigabits per second, terabits per second from our wireless connections. But in these networks, we need to think slightly differently. I don't need gigabits per second from my notebook or from my watch or from my shoes, right? I probably need only very low data rates. What I do care about is battery life. I need it to last the 10 years that I know my AA battery or AAA battery or coin size battery can handle. And if you think about it, for these radios, we did a very careful analysis, and it's quite evident that the biggest factor that this dictates battery life is transmit power. So of all the different components, sleep and RX and so on, transmit dominates your battery life. So which means it's very important to make sure that you transmit at very high data rates and for very short intervals of time to reduce battery life. And this is the key bottleneck that we need to address, which means we need to somehow make sure that transmissions are received correctly at high enough power. If not, we can get a remarkable hit in battery life. So in addressing this question, we came upon sort of a slight change in the IoT revolution as far as low power WANs were concerned. Something that was happening very subtly, but we picked it up a bit early, right? Which is, at some point, this was in 2017, Comcast, which in the US is one of the biggest providers of home wireless, as well as set-top boxes and TV connections and so on, right? Was essentially building a LoRa network of its own, and we were confused. Like, what is a home set-top box provider doing setting up a LoRa network? And it turned out they were deploying LoRa base stations, gateways for these low-power networks inside set-top boxes. So suddenly, we are now in a different environment. We thought we are looking at these big towers that are just in a few different locations that are installed on top of buildings, but now we're going to have a mix. We're going to have some of these towers sitting on the rooftops, but we're also going to have some of these home towers, these mini home towers that are available in set-top boxes at homes that are just deployed everywhere, all over the place. And so we wanted to ask, okay, now it's quite possible that your LoRa radio or your device might have multiple gateways around it, right? Multiple homes and multiple set-top boxes that you can talk to it. And I know we are used to, right, in a world where a cell phone, for example, connects to only one tower, right? There's one tower, and that one tower is what your device talks to. But can we sort of rethink this for the IoT context? Because battery is so important, can we actually use the diversity of all of these gateways around us to improve coverage and improve battery life? And this led to a system called CHARM, which we publish in IPSN, which is a system that essentially leverages a principle called coherent combining from the signal processing world. And the idea is, whenever a client transmits, its signal is not just received by one gateway. Inevitably, wireless is broadcast. Its signal is received by every gateway that surrounds it at some level. Of course, some gateways are going to receive a stronger signal. Some base stations are going to receive stronger signals compared to other towers, right? But they're all going to receive it at some value, some scale by some factor. I call this H1, H2, H3, right? Think of these as three different values that perform the scaling. And you're going to receive slightly differently weakened copies of all of these signals of the clients. What if, rather than decoding them individually at the gateway, why not ship all of these received signals to the cloud, so that at the cloud, you can effectively add them up constructively? So if you remember good old physics, signals can be added constructively or destructively, right? Depending on how what scalars you apply in front of them to boost the signal or cancel out the signal. So could we, in principle, at the cloud, perform this constructive combination process, right? Add up all of these signals coherently so that the receipt power is maximized. And this is the principle of coherent combination that I have here, right? And these are very standard set of equations that let you do this. So in principle, now, remember, it's very interesting, because this client need not get any signal, this signal from this client may not be decodable at all at any single gateway. But at the cloud, we can sort of add it up cleverly so that it's received accurately and the data can be recovered, right? So this sort of brings us to a sort of broader question, right? Okay, let's assume a worst case scenario. Let's assume a worst case scenario where the client signal is so weak that all the gateways sort of don't even perceive that there's something useful to be sent upstream. So in which case, can we actually do this? Can we actually know when to send this information to the cloud and make sure it can be decoded, right? So to better understand how this process works, let's sort of take a step back and better understand what are the signals that we are transmitting? What is the physical layer of this technology called LoRa, which I'm talking about? So let's take a very, very simple sort of view of LoRa, right? And LoRa at a very high level uses this concept called chirp spread spectrum. And what is chirp? Chirp is just a frequency. Chirp is just a signal whose frequency increases linearly with time. So here, for example, if you notice my 0 here, this is initially a low frequency signal. That's frequency is increasing over time, and then later the frequency decreases over time. So on the bottom graph here, I have a spectrogram where you see these yellow bands that correspond to increasing frequency, and then it wraps around and then increases yet again here from the bottom. One is encoded slightly differently. It's encoded this way. So if you don't understand any of this, just look at the bottom two pictures. 0 is encoded by starting this sort of slanted line here. 1 is encoded by starting the slanted line here. So by applying different frequency shifts to this slanting line called a chirp, you can encode different bits. So you can encode a 0 and you can encode a 1. So every one of these chirps effectively encodes 1 bit. But then you might say, hey, this is wasteful. I'm using this entire chirp to encode this 1 bit. Can I do more? Yes, you can. It's a very simple trick. Don't just have 2 starting points, have multiple starting points. So if I want to encode, for example, 2 bits, I need to have 4 possible starting points. Maybe the lowest one, 1/4, maybe here 1/3, 2/3, maybe somewhere else, right? And so on. You can have like different slightly different shifts to the starting point to encode more bits. So now you might ask, okay, I received a signal. Let's suppose I received a signal that was so weak, right, that I didn't even know that there's supposed to be a packet here. And so I don't even know how to send it to the cloud, right? Why would this happen? Why would this ever happen? Now, this happens because typical packet detection is sort of very naive. So suppose, let's say you have a packet here, and this packet in Lora looks like this. So again, you see the familiar chirps, which was those slanting lines that I showed you earlier. But you have slightly different components of it, right? In the first part, you have something called a preamble. This is there in almost any wireless technology. You have some standard sequence, like very regular pattern, just to know that the packet exists. In the beginning, you have some sync symbols that almost form part of the preamble. And then you have data on the right, which has all these different interesting shifts to send 0s and 1s and various combinations of data that you care about, right? And now typically what you do at the receiver is you have a known preamble that looks something like this, some picture like this, that you then correlate, or this more formal term is match filtering, that you sort of pattern match with what you receive, right? And then say, oh, hey, I think I see this pattern appear here. This is the expected pattern. Every packet is supposed to start with the sequence. I see it exactly here, and therefore I know this is somewhere here is where the packet starts. So somewhere here is where the preamble ends, and so on. Right? You can learn that, and the way you do it, there's a threshold process that checks if the match has reached a sufficient threshold, in which case you know that hey, this preamble exists, right? But as you can imagine, this fails when your signal is so weak that it doesn't pass its threshold, right? It fails in very noisy settings where this threshold is simply not reached. So we thought, okay, now we want to decode these very, very weak signals. Let's not do this regular packet detection. Let's do a slightly cleverer packet detection called enhanced detection. And the idea is this. Let's take a step back and look at that picture. Look at the picture with all those slanting lines, with all those chirps. And let's look at the data on that side. Now you can see that this data on the right-hand side is not quite random. It's not quite random. It actually has it has some symmetries. Remember, I told you that for example, encoding 2 bits, you can start your chirp at predetermined points. Let's say a quarter, half, 3/4, 0, right? There are very discrete points where your chirp is allowed to start. So let's imagine the following. Let's take scissors, right? And then cut along those dotted lines that I showed here. So this is a Lora packet that's been received. Let's take some scissors and make some cuts along those lines. And then, I'm going to make you do a little bit of artwork. Let's take all of those chunks and fold them down together. Let's just fold down all of these chunks together in the bottom, right? And then you'll very quickly see that what the picture on the top effectively folds into some picture like in the bottom, right? And this bottom picture looks very regular, eerily regular, in fact. You see some chirps that look this way, you see some chirps that look this way, but then almost all the remaining data chirps, remember this is part of the data, looks identical, right? Looks identical to the preamble. Suddenly you've sort of gotten rid of the data and you have a very, very regular pattern, very similar to the preamble, which is brilliant because now you can rather than just treating the preamble itself for our pattern matching process for detecting the packet, we can now use the entire packet. You can use features in the entire packet to for our pattern matching process, or also called match filtering process, and then find out where the packet exists. So the key idea here is, let's not just use the preamble. The data also has patterns. Even arbitrary data has some patterns because of wireless modulation. So let's use those patterns to try and detect very, very, very weak packets. And these sorts of small optimizations matter a lot when we want to consider improving battery life, right? So that is our observation. Now, the result of doing this is it results in its huge bandwidth savings, right? So rather than, if we didn't do this, one other alternative would be to send everything to the cloud. But sending everything to the cloud would take huge amounts of bandwidth. Remember that some of these gateways are deployed in set-top boxes, right? And in home wireless connections. There is no good way in which we can justify sending 144 megabits per second uplink data from a home set-top box to the cloud all the time, right? Because I'm sure you have other uses for your internet connection, right? We could perhaps justify sending tiny kilobits or few megabits per second of data, right? And that is what our system results in, right? It results in huge bandwidth savings. It only uploads samples when they're needed, which is already great in terms of bandwidth savings. So there's also another challenge that emerges naturally from the system, which is how do we know that, okay, these are the right, so let's say we have multiple copies, right? Remember, each individual gateway now, each individual base station detects a packet. Now they all know that there is a packet, or potentially what looks like a packet here, even if they can't decode it. How do they know it's all the same packet? We need accurate time synchronization between all the different gateways for that, not regular millisecond synchronization, maybe even microsecond synchronization. We achieve this using something called phase-based synchronization. I'm not going to go into details. Very, very high level. The first thing you can do is start with millisecond time synchronization that you can actually already get. You would be surprised, but your phone's clock or your computer's clock is probably already millisecond synchronized because it probes NTP clocks or central clocks typically at reasonable enough times. And we can get even finer synchronization by processing phase measurements of these chirps to within a single sample, like that's even smaller than one of those chirps that I showed you. I'm not going to go into the details because I don't want to go into the weeds of the math. There's another thing that helps us. One question that I almost always get with this sort of a system: hey, you're decoding this entire packet at the cloud, but what about latency? How quickly can the cloud respond and decode the packet and send this upstream? How long can you wait for the packet to be decoded? And now it turns out that this again requires a context switch. Remember, this is not your 5G data, gigabit per second data connection. This is a very low power, low speed connection for IoT devices, for devices that are sending a small amount of data but really care about their battery. And it turns out that acknowledgements for these sorts of technologies are very, very loose. They can be sent as slow as 1 second after the packet is sent. So you have plenty of time to do all of this processing, all of this decoding, and so on. So there's another optimization that we designed in the cloud, which is, what if sometimes our system fails? So I know that we said that we have this enhanced packet detection, but what if your signal is so weak that even your enhanced packet detection fails? Is there something else we could do to salvage that, right? And this it sort of leads to another idea. So let's imagine the following system, right? Let's imagine you have a Lora radio, an IoT device, and there are some gateways which have slightly stronger signal and some gateways that have slightly weaker signal. So some of these gateways are where our enhanced detection succeeds. In some other gateways, the enhanced detection fails. So let's imagine the following. We have three gateways here, three receivers, RX1, RX2, RX3. RX1 is receiving a slightly weaker signal. 2 and 3 are, but still decodable. 2 and 3 are getting terrible signals, like red, the signals are in red. So that means they're extremely below the noise. So our enhanced detection fails. So let's imagine this. right? And let's say that rather than throwing away these signals, what these receivers do is they end up storing it in a circular buffer. So they keep track of these weak signals in a buffer. And then RX1 has has received a slightly stronger signal that it suspects because of our enhanced detection could be a packet, but it's not sure. RX2 and RX3 don't even realize this and think this is all junk, right? But remember, they don't throw it yet. They store it in a buffer, at least temporarily. Now, what RX1 will do is it will send this packet up to the cloud that says, hey, this might be a packet. Could you just look at it and tell me if you think it's a packet? Then the cloud then says, hey, this could be a packet. I'm still not sure. Let me ask the other receivers in that neighborhood, even the receivers that claim they didn't see a packet, to see what did they receive at around this time. Can you tell me if you saw something around this time? This is sort of like imagine this is sort of like a police inspector, like there was a crime reported, and then the police goes and checks the neighborhood if anyone else saw something suspicious around that time, right? So the cloud does that investigation and tries and talks to some of the other receivers to see if something similar was received around that time. And so they request these chunks. Right, these receivers have no idea, but they still remember they stored at least the recent history of what they recorded. So all of these recordings are going to go up to the cloud. And then what the cloud is going to do is going to coherently combine these. And remember, these, even though these signals are in red, if you have enough of them, that might still be sufficient for you to decode the transmission. So the key takeaway here is we don't need enhanced detection to succeed at every single receiver. Even if it succeeds at one receiver, our job is done. So this is similar to saying, hey, if a crime is reported, it's enough if we have one witness or at least one tip, right, to start investigating, right? And so we can do that here. So we went ahead and actually implemented this on a gateway. So this is our sort of front end, which we built on an FPGA platform. We essentially built our own version of a software-defined radio for these frequency bands that interfaces with the Raspberry Pi, so it can be fairly cost-effective. So I actually worked with a colleague at IIT Madras for doing the interfacing with the Raspberry Pi and extending this to some of the other radio technologies. We also added a bunch of auxiliary hardware for some of these existing gateways. So this is what our weatherized sort of case looked like at the end of this process. I'm not going to go into the details of our enhanced detection. It performs significantly better than the traditional local detection and much better than Lora WAN, which is what you see in the blue bars versus our green bars here. The most important thing is that our system results in huge battery savings. It results in 4 to 5 dB of SNR, which is in log scale. So you should remember that that actually amounts to a lot in terms of battery savings. So in terms of battery life, we can get significant improvements. What used to be effectively like maybe a year or half a year of battery life can be boosted to 2.5 years, 5 years, or even 10 years of battery life, depending on how many messages per hour and how many gateways you are deploying in the network to boost system performance. So there are many, many other open questions that we dealt with that I didn't have time to talk about, but I do want to point these to you as well. We also dealt with a frequency selection, picking the right frequency for these radios, performing machine learning inference on these systems, also location tracking of these devices, and all of these led to subsequent follow-up papers as well. And this is certainly a very rich area that I would encourage all of you to work on. It's something that you can deploy for extremely low cost, but with extremely high impact, right? That's the kind of system this is. And there is an IoT revolution happening in India as well. So if you are interested in any of these platforms, I'd encourage you to connect to the OpenCMU wireless IoT infrastructure, which is live right now. We have a bunch of these rooftop gateways. We have CMUs as well as City of Pittsburgh infrastructure like traffic lights and buses already connected to this network. We have a lot of signals happening at the that are being sent to the cloud. We use this for 5 radar protocols, some of the location tracking protocols I'll talk about, but also for sensing applications. And I added ... here because you can come and fill in the blanks whenever you can, if you have your own favorite technology to track. So so far I've been talking about low power WANs. right? So which is, hey, let's attach a tiny radio and a battery and get few kilobits per second, right, to this receiver. But then one might ask, okay, can I somehow get rid of this battery? I don't like a battery. Can I get rid of it, right? Unfortunately, you can't do this within FCC limits today because there you'll break something called either Shannon capacity theorem, or you will break FCC or local government regulations on how much power you can transmit. All right. So if you look at the technologies for batteryless systems today, what they can achieve in terms of range is like of the order of 10 meters, right? Which is not great, but reasonable enough for a whole bunch of applications. Can we do better is another question we wanted to ask. Can we build something like low power bands, or at least not something better than 10 meters with batteryless systems? So what batteryless system am I talking about? I'm talking about RFID tags, or radio frequency identification tags. These are tags that look like this. They have a coil. They don't have a battery at all. They just have a tiny chip and a antenna that's what looks like a coil there that harvests energy from the reader and from the environment. So if you are not familiar with RFID tags, you should be. Starting 2021, they will be in all Indian passports that are newly issued for identification. If you are buying a new car in India, you are supposed to install something called FASTag, which is a toll transponder system that again uses RFID technology. And if you ever use the Delhi Metro or any of the metro systems in India or elsewhere, or bus passes, for example, that are similar, and you tap them, that has an RFID tag inside it, or your ID card of your organization might have an RFID tag inside it as well. And so what's happening when you do this tapping process is that the station behind that you tap in is called the reader. This provides wireless energy, and the tag is inside the card. Your credit card or your bus pass or metro card doesn't have a battery. It instead harvests energy from the reader and responds to the reader's signal. Another place where you have RFIDs, which you might not realize, is if you peel open your baggage tag in the airport, you might find something that looks suspiciously metallic like this, which again is an RFID tag. And then you might ask, hey, if there are RFID tags on my luggage, why do airlines lose my bags all the time, right? And it turns out the reason is because RFIDs are range limited. So imagine a baggage beltway here, and you're going and collecting your luggage or dropping off your luggage. There's a bunch of readers here, as well as tags attached to these to the luggage, as we saw earlier. Right? Today, these bags can only be scanned from about 5 to 10 meters around the readers, not much further. And this is not sufficient, right? The bags could be lost anywhere in between as it's sort of going through the beltway or anywhere else through the system. Now, ideally, we want something that's much bigger, like several times bigger, that covers the entire space with all of these readers. So could we do something better, right? So this is what our system does, a system called Push ID, which effectively expands the range of these RFIDs to the entire space. So how does it do that? Our approach is, again, use collaboration. We saw using collaboration in CHARM in the low power WAN context. Could we do the same sort of collaboration between readers in the RFID context? So here we have an unmodified tag. So we are not asking you to buy new RFID tags or buy new passports or get new luggage. We want to reuse the same infrastructure that's out there for the tags. And we just want to make the readers, even existing readers, collaborate with each other to improve performance and range. So how does it work? This is sort of a reverse problem of what we saw earlier. Remember, the RFIDs need to harvest energy. So can we somehow make all of these readers work together to beam power exactly at the tag, right? And so if the tag moves at a different location, we can again beam power at that new location, right? So the new tag can be formed, right? But the moment you have this beaming power, you have a chicken or egg problem. So remember, to beam power, you must know something about where the tag is. Something, the more technical term is you need to know the wireless channel to where from the tag, right? But for you to know where the tag is, the tag needs to say something. But for it to say something, it needs to have energy. To have energy, you need to beam power. So you have this chicken or egg problem. Do you beam power to the tag first, or do you know the tag's location first, right? There's a chicken or egg problem. Right? So our solution to address this models signal power. So we effectively model how signal power propagates over space. Now, if you, again, going back to constructive and destructive interference from high school, you should remember that wireless signals are also, oh, could you mute? I'm not sure who that is. Okay, I think I did it. So to model how signals sort of propagate in the environment, you have this, you again have this concept of constructive and destructive interference. You have a whole bunch of different devices that are all transmitting. You have some bright spots like the one in the center and elsewhere where the signals add up constructively. You have these dark spots where the signals add up destructively. If lucky for you, it happens so that the RFID tag is in a point of constructive interference, it's great, right? It can harvest enough energy and talk to you, but you're unlucky if it's destructive interference. So how do you deal with it? So our technical novelty and secret sauce is in sort of scanning with different forms of patterns so that all the RFIDs in the environment can be activated. Now, this way we can not just activate all of these tags, we can also find their location, which is very powerful. Now, the exact algorithm to scan it is something called a blind beamforming algorithm, which actually finds the smallest number of these patterns of constructive destructive interference that covers the entire space. So I'll refer you to our research paper to learn more about that. But the end result is we can actually do much bigger range. We can get 8-fold the range and much further than what past work can do. And this kind of scales with number of readers with 8, you sort of get this smooth increase in range as you install more and more readers in the environment, right? About 64 meters, as opposed to the few meters, 10 meters max that you get with commercial RFIDs. So at this point, I wanted to show you a few different videos of some of the other kooky, crazy things that we are doing with this same concept. And one thing I wanted to show you about is a system we call software-defined cooking. And so we realized this concept of constructive destructive interference that you're seeing, we saw in beaming energy to RFIDs also applies in another place where we beam wireless energy, which is a microwave oven. So what we did is we put a whole bunch of these LED lights that are energy harvesting inside a regular microwave oven. And you see again, all these microwave ovens sort of glowing in different patterns of light. And what are those patterns? They're exactly the patterns of constructive destructive interference. And I love these constructive destructive interference for beaming energy to RFIDs, but I absolutely hate this constructive destructive interference in a microwave. Why? Because if you've ever got a cold spot while reheating your naan or your pizza on a microwave oven, this is precisely why, right? There's a point of destructive interference where the food doesn't heat up. So we asked, hey, this is a wireless system. I mean, microwave literally is using microwave frequencies, just like Wi-Fi, right? Could we engineer it to do better patterns and build better cooking? So we call this software-defined cooking. So we effectively went ahead and built the system. So on the top there, what you see is wet thermal paper. And here the black spots are where are the hot spots, which is a bad thing because you want the heat to spread uniformly, not concentrated in some locations. Now you know that there's the turntable on the microwave oven, which sort of rotates. There's a reason for that. It tries to spread around the heat, but on the top right, you see that it's not really doing a good job, right? What it's doing is essentially smearing the spots all around, which is not quite what you want. Instead, with our system, we were able to redirect the heat more uniformly. And in fact, we could even make interesting patterns. Mobicom was a conference we submitted and this paper appeared in. So we could do all sorts of fun things with constructive and destructive interference. So this really is a good segue for the last module in the last 5 minutes on the talk, which is about what are the interesting things we can do, right, with this system, right? So far, I really talked about finding the location of one tag in the environment, right? But you could, in principle, do other things, right? In fact, if you have an array of tags, why stop with one tag? If you have an array of tags on any surface, as well as a single reader, you could, in principle, find the shape of the surface of all of these different RFID tags. So we actually went ahead and built this and wanted to build these sort of shape-aware surfaces. So put a whole bunch of RFID tags on things. They're cheap. They cost a few cents each. They're machine washable. They're batteryless. So you can just put them on anything. You can put any number of them on anything. So what could we do with it? So this is what we built. One of these, this is a less than $1 touch screen a 3D touchscreen, in fact, that we attach to a whole bunch of surfaces, and it can measure exactly where your hand is on the surface. There are RFID tags that are embedded underneath, so you don't see them. And you can also measure the exact pressure to which you're pressing the surface if you see the bottom right as well. So we can build very low-cost touch screens, right, using RFID technology. We can also build a gesture tracking system. So this is you can see the RFID tag sort of scotch taped in onto clothing to measure how the user's sort of hands are moving. So I call this the glorified protractor, but it's a protractor that works even if the reader is in the pocket. And you can potentially be jogging, and you don't need to have a camera looking at you all the time. You still can have a reader that's in your pocket that's scanning all of these RFID tags. We could do a lot of other things. Why just angles? We could also measure curvature. So imagine RFID tags attached to the spine, effectively modeling and measuring the curvature of your body when you pick up heavy loads. We could do a bunch of those with location tracking as well, right? We could also do smart home tracking systems, which is, hey, this pillow knows when you are sleeping. My student also wanted to show a demo of fat shaming carpets that will tell you if you've gained weight, but I thought that was a bad idea. But we can also do shape sensing in other contexts, right, beyond the smart home. So here are a few examples of systems that we're working on right now. So we are collaborating with Bridgestone Tires, a major manufacturer of tires in the world, to build shape-aware tires. So today, if you've ever, if you own a car, you probably know what I'm talking about, or you had your car inspected. One of the things they do is put a coin in there to check how much the tire has worn out. But this is something that you do only every 6 months, every year. If your tire gets worn out in the middle, you might skid. And half of all accidents in automobile accidents in the world are tire related in some way. Right, so we wanted to use the collision radars, or specifically millimeter wave radars, on the cars as RFID readers, and strips of metal wiring that's already present in the tire as an RFID tag. So we wanted to transform this system that is intrinsically not an RFID system into an RFID system. What is this millimeter wave radar? If you've ever seen these advanced cars that do collision avoidance, that sort of brake before they hit the next car, that radar is basically a millimeter wave radar. It's a radar that measures how far away you are from the next car, but we can repurpose those radars to do sensing of tires as well. And so the advantage of this is, just like you have a dashboard sort of measurement of tire pressure and other things on advanced cars, you can also get accuracy of how worn out your tire is in a way that's resilient to debris, easy to manufacture, and so on. And so we actually built this imaging system. We deployed it, we published it, and it's currently being deployed by Bridgestone on their next generation truck tires. We also did bridge sensing and smart city sensing for shape-aware bridges. Bridges in the US are in need of serious repair, and I live in Pittsburgh, the city of bridges, where we have several of these very long suspension bridges from the Iron Revolution that happened at Pittsburgh. So we went ahead and instrumented a whole bunch of RFIDs for shape sensing at a very large scale on these bridges, and then found that those measurements align quite closely with the schematic. I also want to show one final application on sensing use the shape using even one tag. So far I showed you what we can do with many tags, but we can do something powerful even with a few tags. So we actually collaborated with material scientists to build these sort of flexible, thin RFID tags called RFID tattoos that are skin friendly, safe, and sort of are stretchable, made of stretchable materials. So if you've ever used these old school transistors, the old radios, you know that if you pull the antenna longer and shorter, you get better and poorer reception. At least people from a generation prior to, one or two generations prior to me know what I'm talking about, and all the mechanics that you have to do with the antenna to get good radio working, right? So I was a bit inspired by that. So what is actually happening there is, if you stretch an RFID tag, you can actually end up increasing its length, and that changes the wavelength of the signals that you respond to, and that changes the frequency that you can respond to. And this frequency difference is quite a lot. Even 1 millimeter of stretch gives you 8 megahertz of frequency shift. So we wanted to use this system for a bio application, because I'm talking about tattoos, for helping persons with voice disabilities, so people whose throat is not able to produce sound, we wanted those users who lost their voice recently to be able to produce speech. And the way we did it is we wanted to sense the intended speech using facial gesture measurements, and then we wanted to synthetically relay that through a text-to-speech converter. So we actually built this end-to-end system that was in UBCom. And so you see the RFID tags exposed here, but they could be buried under makeup, and it sort of effectively reproduces the speech that the user is intending to say, even without producing it. So I hopefully showed you that there are many, many different applications that we can achieve by, we've connected more than 5 billion, maybe 7 billion users. There are tens of billions more to go to get to a connected world. And so hopefully I showed you some of the ways in which we can not leave behind all of these objects that are left in the world, and also show the enormous sensing opportunities that wireless networks of the future and IoT of the future can enable, and really achieve this long-standing vision in the human-computer interfaces community that we need to build sensing that can disappear, and wireless could be that. So thank you for having me again, and I'm happy to take questions.
Wow, that was a fascinating talk, Professor Swarun. Very inspiring. There is a lot of question that has come in. So maybe what I'll do is I'll very quickly read the question in sequence. And if we run out of time, I would request that you be available to respond them over email or whatever means. Yeah.
Yes.
So the first question comes from Dibakar Das. And the question goes, from implementation perspective, 3 routers with different technologies. This is on slide number 20. Do you plan to tunnel the PHY data over those different technologies to combine on cloud?
Right now, we are using we are assuming that all of those devices are using the same radio technology, underlying radio technology. So they're all Lora based, and we are tunneling that to the cloud. So I think that's perfectly the right picture. Could we do it with other different radio technologies? You actually preempted some of the work that I've been actually doing with my IIT Madras collaborator, with Professor Shivram Murthy's team and others. And we actually published a paper recently on cross-technology communication, which is, could we, in principle, listen to different radio technologies from a single gateway, and what are the interesting opportunities we could do there? So in principle, yes, it could be different radio technologies, but for the talk that I presented today, it is just one radio technology.
Okay, thank you. The next question is from Prashant Mishra. So Prashant, if you would like to voice over, please do so. Since I don't hear him, I probably will quickly read it. Is
Sure.
the CSS code modulated into the I part or Q part? Is the code modulated onto the I part? The correct match should only be located in the I part of the signal. However, as the phase of the acquired signal is unknown, the I part of the signal generated may not necessarily correspond to its recovered version. How do you overcome it?
Okay, I'm so happy to have all these detailed questions. The way to think about this is, think about chirp modulation as a glorified frequency modulation, right? Effectively, what it's doing is it's encoding the starting frequency, right? So in principle, rather than thinking about it as I's and Q's, the way I think about it is, it's just frequency shifting the wave at different bands. That's the easiest way to think about it. Now, why do we still need to measure phase and need to account for phase and so on? If you want to make sure that these signals are adding up constructively, they have to be phase matched. If they are not phase matched, you might get destructive interference. Remember, phase shift of pi is like -1, right? So you might just add them up incorrectly. So the phase correction and synchronization that we're doing is not directly related to the modulation per se. It's just related to the concept that we need to add things up. We don't want to subtract them out, right? So I would see these two as like slightly orthogonal things.
Okay, thank you. That move to the next question. This is from Navanita Das. The question goes, to avoid the use of cloud, is it possible to use smarter gateways to improve the signal strength locally?
Yes, fantastic. Well, collaborate with me. I'd love to know how we can do that. So we actually have an FPGA on some of these devices, right? And so we are thinking of what are some of the ways in which you can do better processing. Enhanced detection was one of the processing techniques that we used at the gateway. With the advent of edge computing, there's every opportunity to do more. One thing to keep in mind with the Lora technologies that we are using right now is they anyway implement the Mac in the cloud for simplicity, again, for device simplicity. So it's not like we artificially introduced the cloud randomly. The cloud was already there, was already being used. We just added another layer to it. But absolutely, if some of the processing could be, some pre-processing at least, could be done at the edge, that would make it much more powerful. And I'd love to learn about what you have in mind. So maybe there's a collaboration opportunity there.
Yeah, Swarun, just a thought from my side. Probably 5G edge computing could be a good hosting place for offloading that computational part rather than going all the way to the cloud. But yes, like you said, we can discuss offline on that.
Yep.
Yeah, the next question comes from Prashant again. What is your take on compression techniques for sending compressed packets to the cloud?
Absolutely possible. So after our work, there's been follow-up work that again appeared more people, not from my group, some other group, right? That did compression techniques on sort of on IQ data. So there have been a bunch of teams that have sort of followed up on our work on efficient ways of compressing it. Actually, there's a lot of compression opportunities if you think about it. This modulation is very dumb, right? Not dumb because it's wrong, it's a bad design, because it has to be simple. It's a low power device, it's being powered by a tiny battery. You can't build something super complicated. And so there are plenty of compression opportunities because it's a simple dumb modulation. And there have been teams that have looked at it. And I think there's a lot of work to be done there as well. Also in CRAN and Cloud RAN and the analog of this in the 5G world, there's a lot of compression opportunities there.
Okay, so thank you. The next question is from Vignoraj. Is relaying multi-hop relay routing gateways can be one of the further improvement in battery life?
Absolutely possible. The only caveat there is that I'll be very honest with you. This multi-hop and relaying sort of process has had these ebbs and flows over and ad hoc networking has had these ebbs and flows over the years. What the main reason why it didn't take off, like the original sensor networking vision of ad hoc mesh-based networking didn't take off in the same way, is reliability and also economics, right? You want to have somebody to bill you, right? And it's harder to bill and provide guarantees if you have a very distributed architecture. So multi-hop, I think from a technology perspective, is a very reasonable solution. From an economics perspective, capitalism perspective, right, it's been harder to sell to the providers, which is why I think this sort of direction is taking off now. Oh, I think we lost Subhash. It looks like. Let me see if I can.
So I will read the next question. So it's from Mr. Ganeshan. So he says that his understanding is that this is built on the principle of asynchronous MAC. Many studies have shown issues in the scalability of systems such as Lora, which also works on asynchronous MAC technology. So what is your experience on that? That is how to find the requirement of number of gateways for the given number of IoT clients or tags for a certain bit error ratio. Does the ratio of number of clients to the number of gateways converge to a finite number?
Oh, that is a great question. I think I think there's so let me be very honest with you. Like there are scalability questions with Lora, but it's not been tested as yet to its full extent. I'll tell you why. Because remember that in principle, like if you look at the 5G and 6G, I guess 5G specifications, right? It is the pie in the sky original 5G specification. I know the IoT fragments of these are not fully finalized yet. They want like millions of devices per square kilometer and so on of support. I don't think we have networks that have really tried and tested that level of scalability yet. I wish Pittsburgh is a place where we could do it. I think India is easily a place where you can demonstrate it, because we have no scaling is something we can do. We just do organically, right? So it's and in a dense place like, for example, Delhi or Mumbai, in some of these regions, you would need actually 1 million devices per square kilometer. It's quite possible that you reach those scaling limits. At those scaling limits, will Lora succeed? I can bet you it will not. We actually wrote papers about it, but so is Lora the right physical layer technology for scalability? I am not quite sure it is, but it is a commercial entity. It is widely being deployed everywhere. So sometimes rather than building the perfect technology that we want, let's live with what we have and try to make it better is sort of what I'm working on right now. The other pie in the sky question is something I'm always constantly thinking about too. I think we should all think about it in academia.
Thank you. The next question is from Gerard Berry. So he says, connecting lots of objects is also the goal of 5G networks. How could that fit into your approach or be compatible with it?
Yeah, I didn't mention this, but narrowband IoT is one of the technologies that are emerging as parts of the 5G standard, and already they're in earlier versions that tries to do connectivity on just reusing cellular base stations. The modulation technology is different. The concept of coherent combining, the concept of location tracking they all extend. I mean, of course, the details would change. Right, so very much this fits in 5G architectures too, and we are actually talking with AT&T on some of their experimental NB-IoT deployments.
Thank you. Then the next question is from Chengappa. He says that would LoRaWAN and 5G complement or competing technology? Especially, how would they cater to IoT network or connectivity?
Initially I thought Lora would die. I'll be honest with you. Because I thought, hey, here's this open technology, and how will they compete? NB-IoT will come and eat everything up. And then I realized NB-IoT has some problems, like compatibility issues, so it's not perfect. Second, by that token, Wi-Fi should have died. LTE, 3G, whatever, 5G, everything exists now. So will Wi-Fi die? No, because you can set it up at home. It's unlicensed. You can administer it. An enterprise, let's say you work for your company will hesitate to install a Geo or whatever router there, but they're very happy to install their own Wi-Fi because they know they're in control of the data, they're in control of the base stations and so on. So I believe a similar dichotomy will emerge with unlicensed LoRa being sort of this enterprise or city IoT networks, and cellular being the other sort of world, which is the for everywhere else, the remote areas, when you're on the street and so on. So I think there will be that duopoly there, right, in a similar vein.
Thank you. The next question is from Rohit Reddy, and he says that he believes that RFID sensing will be the key in connecting devices. So could you please share what are the key challenges in RFID sensing?
Oh, there are many. I think I can't finish this in one. Let me just add one sentence that says that, hey, location tracking is just the start, but sensing, various medical applications, sensitivity analysis, reducing the cost, improving functionality, building custom tags for some of these applications. All of these are open problems. We've just scratched the surface so far.
I think, Prashant, that completes all the questions.
Yeah, I think that's right. I think the presentation slides would be shared with the participants. That is what the question is.
Yes, I'm happy to.
Yeah, thank you. I think that and.
All right, thank you so much.
Yeah, thank you so much, Swarun. It has been an amazing talk. A lot of takeaways. So with that, I think we'll shift to the next part of the question. And Prashant, thank you for filling me in when I had little connectivity issue. I hope I am audible now, right?
Yeah.
Yes, Subhash, you're audible.
Okay. All right. So with that, we shift to the panel discussion. I am very happy to welcome Dr. Aloknath De, Chair of IEEE Communications Society Bangalore chapter, who has kindly agreed to moderate this panel session, and it is going to be an interesting one. So let me briefly introduce Dr. Aloknath De. Dr. Aloknath De doesn't require any introduction. He has been the face of, I would say, India to create that innovation ecosystem and how to nurture the research and create a research mindset in the ecosystem. So Dr. De is a corporate vice president of Samsung Electronics and chief technology officer of Samsung R&D Institute India in Bangalore, where he is responsible for Samsung's IoT data platform and advanced services. Dr. De is considered one of the most influential CIO CTO of India. He is recipient of the Alexander Graham Bell Prize in Canada. He has also received IEEE Memorial Awards for distinguished contributions in electronics and communications, IT Insight Award for innovation, and the list goes on. Dr. De promotes science and technology linkages through IP creation, startup collaboration, and innovation solutions. In addition to more than 30 years of industrial and research experience, including BHEL, Nortel, Hughes, ST Ericsson, and most recently here in Samsung. He also served as a visiting professor with IIT Roorkee and IIT Delhi over an extended period. Dr. De holds a BTech from IIT Kharagpur, my alma mater, and ME from IISc, and the PhD from McGill University, Montreal. Dr. Alok, welcome and thank you for agreeing to moderate this session. And now I would like to invite Prashant to introduce Dr. Shrija Sukumaran, who is an assistant professor of Christ University. Prashant, over to you.
Yeah. Thanks, Subhash. So we have Dr. Shrija Sukumaran from Christ University. Dr. Shrija is currently working as assistant professor in Department of Computer Science, Christ Bangalore. Her areas of interest in research includes, but not limited to, information security, authentication, biomolecular computing, DNA cryptography, and public key cryptography. She has published her research work in peer-reviewed journals, including Elsevier, InterScience, and in proceedings of renowned international conferences, IEEE and ACM. She also received a thesis award for her PhD thesis during Graduate Congress 2019. She has also served as a reviewer for prestigious IEEE conferences, session chair, and publications co-chair for IEEE PhD Colloquium on Ethically Driven Innovation, Technology for Society 2019 and 2020. She's an active IEEE ComSoc Execom member. So welcome, Dr. Shrija.
Thank you.
Thanks, Prashant. Shrija ma'am, could you please come on camera? And I request all the panel members to come on camera, please.
Yes,
With that, I will introduce and welcome Dr. Avinav Kumar on this panel. Dr. Avinav Kumar is an associate professor of IIT Hyderabad. Dr. Avinav Kumar received his BTech, MTech, and PhD degree from Indian Institute of Technology, Delhi. He has worked on a postdoctoral fellow at the University of Waterloo, Canada. Since November 2014, he has been with Indian Institute of Technology, Hyderabad, where he is currently an associate professor. His research interests are in various aspects of wireless communication and networking, including energy efficiency, visible light-based communication, cellular IoT, resource allocation, and multiple access techniques in heterogeneous network. He is a senior member of IEEE. Welcome, Dr. Avinav. With that, I request Prashant again to introduce Dr. Pinaki Bhaskar, who is a senior. Yeah. Prashant,
Thanks, Subhash. Yeah, so Dr. Pinaki Bhaskar is the Senior Chief Engineer at Samsung Research India. He's working in Advanced Technology Lab in Samsung Research India, Bangalore. He's an active researcher on AI, ML, deep learning, and NLP for over 12 years. His main area of research is artificial intelligence, application of deep learning, question answering, and multi-document summarization. Before joining Samsung, he was postdoctoral fellow in the National Research Center in Pisa, Italy, where he worked on biomedical question answering systems. He also worked as a guest faculty, senior research engineer, junior research fellow, and junior research engineer in Computer Science Engineering Department, Jadavpur University, India. Dr. Pinaki completed his BTech, MTech, and PhD on answering questions from multiple documents, the role of multi-document summarization from Jadavpur University. So welcome Dr. Pinaki Bhaskar to this panel discussion.
Thank you. Thank you. Thank you. Happy to be participating.
Subhash.
Yeah, thanks, Prashant. And Dr. Swarun, welcome again to this panel discussion. With that introduction, Dr. Alok, please take the floor.
Thank you. Thank you very much, Dr. Swarun. Wonderful talk. And, I really thank Rajiv, Prashant, Suvas, Chengappa for making this thing happen. It is a Thursday evening. So many people joining. I see IEEE Bangalore, Delhi, IIT Delhi, many faculties, ACM and INAE members joining. So thanks to all the attendees in this evening. And I don't want to leave any opportunity. When I heard that, Dr. Swarun is, ready to talk about this wireless network and IoT. First of all, that's my field and I was so keen, but also I felt it's absolutely important. India is going through a phase, the development, the D part of it, we have been doing quite well. But for long-term business growth, the R part is also essential. I mean, short-term, there are, lots of shortcuts, but there are no shortcuts for the long-term growth. And I think we are recognizing it. And I didn't want to leave this opportunity to put all these people together. Pinaki has been working, Srijam also with me in the EXICOM. Avinav has worked with me in IIT Delhi, Masters. So again, welcome. And since all of us have the doctor, so I will take off for the discussions part and call everybody by first name. I hope it's all right. So with that note, I think what we wanted to discuss simply is how to create a research mindset. So the word research is the focus. The mindset is an important part. And then we'll come to creation part of it. And two parts of the discussions. One, first, maybe you yourself, as you did your PhD and other kinds of research, how you see it. And towards second up, we will move to, as you are guiding your people, the students, how are that changing? And it's not always that if you do well, doesn't mean, we could impart it or, you get, depending on which universities. We are in a spectrum of universities and industry that people are there. What are the challenges? So that's the kind of scope that we will keep it in next 40-45 minutes. So if I may ask, first question, and we'll go around. Maybe we'll start with Swarun, Pinaki, Srija, and then Avinav in that order, so you can think it up. But what in your mind is the attributes of a research mindset? What do we mean by, we call it scout mindset, and different kinds of mindset research? I think to make it happen, I believe that mindset is absolutely essential. So what are the attributes of this research mindset? And I could just take, there is this microwave example where you talked about Movicom. That's the fun part of it. So it's not always a serious part. The fat shaming carpet that you mentioned, there is a lot of fun that we could have on the research. And then obviously with few simple tags that you were talking about, sensing speech for persons with disabilities. So I could put the spectrum in front of the audience and to yourself, and then I'll repeat the question. What, in your opinion, are the good attributes of a research mindset? Thank you.
All right. Thanks for the question. I think it's hard to answer what is a research mindset. So I'm actually reminded of something that Professor Pandurangan, who was my BTech advisor at IIT Madras, used to say to me. He said, I can put you at gunpoint and get you maybe I was not doing good research at that time. I can put you at gunpoint and force you to give me money. I can force you to do this, solve this math problem, but I don't think I can force you to do research, because there's no such, the research has to sort of come from within. It's hard to force somebody to do good research. And I think this is sort of it has to sort of come from within. It's a creative spark. For some people, it's problems that they experience every day, like, okay, my microwave oven is not cooking well, or problems that they sort of see around, the societal impact that they want to make. and that gives them the spark. For some people, it's about interacting with others, sometimes outside their field. And that's when they see a connection that wasn't very easy to be made. For some people, it's just about, let me read a lot of papers and then something will come, right? So I don't know what really constitutes a research mindset or a valid approach to finding research problems and thinking about research. But I do know one thing, right? Having fun and being positive about it and being inspired by and enjoying research is one important aspect of it, because if you don't, it's really hard, because particularly things like PhD or faculty life is a very long experience, right, with lots of failures before you get to the success. So you need to constantly be inspired by what you do and what others around you do.
Yeah, so yeah, rightly as Saran mentioned that it's really very subjective, like it's not same for everyone. But if you like summarize and abstractly, if you have to see, so definitely one thing that you have to be have open mindset and some kind of creative mindset, because like research, I can see there are two kind of research, like it's not always innovation, it's also sometimes to improve something or some kind of enhancement, right? So for both the cases, you have to think openly and to come up with some solution where you solve some problem. So that mindset is required, and rightly mentioned by Saran, it's a long term assignment, or like when you do PhD, like it's almost like 4 or 5 years, then you join the academics or industry. So it's a long term process. So you have to be very patient also. Like it's very difficult, like sometimes that you lose motivation and you judge yourself like what you are doing or whether you are getting the correct outcome or not. So that patience is very much required.
So patience and intrinsic motivations are very important, as you're saying.
Yes.
Srija, how do you see
Yes,
that?
sir. The first attribute I would like to say as creativity, I am telling from my own perspective, because when the subject, my research subject, that is what I was thinking. But creativity alone might not be enough. So the commitment factor comes in when we are into PhD, because unless and until you're not systematic, you're not able to get what really you want within that particular time. And self-motivation is one of the important factor, because and self-motivation comes if you're passionate. If you are passionate about what you're doing, then I think self-motivation comes in. And I do believe communication and writing skills also important. This is something which I realized in the first year of PhD, because though I know what I'm doing, another thing to convey what I really wanted to do and to present and convey, this is what I am planning. So these attributes are also important. So for me, if I say, yeah, these are the attributes which are really important, and patience is also one of the important factors.
Sure. Yeah, patience, perseverance, passion, all of this are important, as you're saying. But you also said one interesting thing, that being creative yet systematic. So some kind of discipline is also very, very vital in your opinion, right? Avinav?
Yes, I completely agree with most of the things. And I would like to add one more thing to that discussion, that when you are trying to, solve any research problem, a certain level of critical thinking is very important, because if you're going to just read and understand the concept, like, people in their bachelor's or some people in the master's without thesis also do, then typically it's very difficult to get any new research outcome. You need to look at the thing, but at the same time evaluate all the assumptions critically, and then maybe there is always a possibility of you thinking something new, something impactful, which can result into good research. So I believe, in addition to all that has been mentioned, maybe critical thinking is also very important.
So I know this question is a bit abstract and we can have answered that much, but if I take like a specific examples, either your doctoral thesis itself or maybe some other research, when you did that, with reference to that, could you say that how did you arrive at the problem? We saw a good example when Swarun was explaining, from the mobile to connections to why not expand to other devices and things like that. But if you, Avinav, you would like to start by giving some specific examples, either you hit a road, block and you change directions and things. How did you search the problem that you want to solve that is impactful, that's meaningful?
Sure. So I think in that context, I would count myself as lucky that my supervisor in both masters, that is you, as well as in the PhD domain, was supportive. They let me choose, in some sense, the domain, gave me the freedom initially early on in the program to explore options and come up with some sort of research questions, and then they helped me select that maybe this one is more impactful. So I think there a lot of it depends on your supervisor also, because they typically have more exposure. It's easy for them to make that judgment call. Plus, I think overall exposure is very important while selecting a research problem. So somebody who has just done some coursework and is not very well connected with what is the current state of the art, it's very difficult for them to make a good, judgment call as to whether this particular topic is, let's say, something worthy for PhD research or not. So I think exposure is really important. And in that context, I think during my PhD days, it was co-funded through some Canadian funding, and I was able to visit UBC early on. So that helped. The exposure really helped me make a choice as to which problem, I should be working on.
So what you are telling is, on one hand, your own interests is important, and that's, helps you to make a bigger list. But then among them, which one to do, that's where you need either exposures yourself and the guidance also from the supervisors,
Yes.
right?
Yes.
Any specific examples? And if you would like to highlight what the thesis was, that's also fine. Srija, you are mute. Yeah.
Yes, sir. So in my case also, I was fortunate that my guide said you can select whatever the topic you are interested in. So actually, I wanted to go with cryptography, but not the regular one, like doing with the cryptography, RSA algorithm, all like extensive work has been done. So I wanted to do something novel. So I came up with DNA computing when I was looking into the first proposal, that is the base paper proposed, same one of the person from RSA algorithm who had proposed it. So when I went on with this particular topic, my guide also suggested, yeah, it's good to go with. So that freedom was given, and DNA computing is something really I was passionate about later. In the earlier stage, I wanted to do, but I was not really clear about it. But later, I became so much interested that I really wanted to continue with that. Though there were some of constraints. When I say DNA cryptography, getting funding and other things was really difficult, because it's not the typical cryptography concepts where we can implement or not feasibility. So some constraints was there. But then I was really happy with what I was doing. So I feel that is more important. The topic you choose should be of your interest. That itself will motivate you to complete what you started with.
Right.
Just one point I felt. Yeah.
Very good. Pinaki, I just wanted to ask you, we can't see you, but we'll ask you. The question is, since you joined industry, did you know before when you were doing PhD that you will not be joining academics? And if you were deciding, has it in any way influenced your research there in the PhD time itself?
No, not really. Actually, while I was doing my master's and PhD, I never thought that I will join like specifically industry. Like I was open to everything, but my journey was little different. When I was doing my master's, I got an opportunity to work on a certain government projects called cross-lingual information access. So for that project, actually, my work was to develop the summarization system to generate the snippet. So that's how my master's thesis was on summarization. Then I eventually decided to do the PhD. Then my guide was open also because I was on the NLP domain. I already had the exposure on that domain. So I decided to take the real life example, like problems like question answering, how to solve that, because at that time and even now also, say, most difficult problem in NLP domain. So that's how I was motivated, and I was choose my PhD thesis like that. And fortunately, in my postdoc also, I joined the similar kind of group, and then I worked on the biomedical question answering. And specifically, during my PhD, during my postdoc, I decided to join Samsung, though I had several other options also. And then I was fortunate enough to join in under your department, like Advanced Technology Lab. So like there, we got a variety of exposure of doing a lot of things on the text intelligence. So that was my journey. So for me also, the takeout is the exposure is very much important. Like so that's why whoever does not have exposure, so I feel in my Jadavpur University scheme also, like whoever joined, they had to spend like 1 or 2 years to study the literature survey and get that exposure, then come up with a perfect like problem for their thesis. So that's how I think.
Great, great.
Yeah.
So Sarun, I will just expand this scope of the question a bit, not just for yourself, but do you have some tips as to how to search a good problem, how to navigate this space of it, not the exact definition of the problem, but.
Okay, that's a very hard question. Let me try and there's no one magic formula. I wish there were. It's very subjective. I think rule number one, I think it was mentioned by many panelists before, choose a problem that's close to your heart, that inspires you, that doesn't, because you are going to have to work on it all day and night, for many, work on deadlines and fail multiple times. So it has to be something that inspires you. Where you pick it up from could be anything, could be something that affects your family, something that affects the society around you, some everyday experience, or a paper that you read and then a spark hit you that, hey, why don't I apply this in a different domain? A discussion that you had with a colleague, a discussion that you had with an advisor about some random topic, something that you learned in a course. There could be so many different sources of inspiration for the problem. But I think one thing that was mentioned by a lot of people, I want to highlight it, which is having that sanity check discussion with your advisor, with good colleagues, to make sure doing a very careful literature survey, being nimble. So if because literature is constantly moving, so something new might come up, and then you shouldn't be blindsided by that. Being thinking, having sort of a systems and systematic mindset, making sure that you cover all the different aspects of it. Also, sometimes this has happened to me, and I have also faced this from my students, just having a fight with your advisor to make sure that you both agree on what to do, right? So all of these have become a part of this problem search process. But actually, the hard part in a PhD and in research is identifying the problem. I think once you have a good problem, and at least a reasonable starting point for a solution, after that, things become easier gradually, right? Identifying the problem is the hardest part.
Yes, so I think, all of you are bringing out that topic of having the exposures, but, those who are starting, they could have only that much exposure. So obviously you need to rely on supervisors and some of the senior colleagues and other people who could give you tips, look into this, look into that, and then therefore you do. But once you do that, you again repeated the point that it's a very creative process, but also disciplined, like look into a whole set of literature. The importance of literature survey, as you brought in, is very, very vital, because you might be excited, it's good, but it has been solved. It might be a very crowded place. Do you want to enter? Sometimes it might be a conscious decision that I can do better than this, even though it's a crowded space, but you have to have that courage and the willingness and the experience to do that. Or you would like to say that, no, that's not something, this is what is going to be coming in next 5 years, 7 years, and therefore let me look into that problem. So it's a personal decisions the way you want to do. So anyone else want to highlight on the importance of literature survey, or did you progress to some extent and then you realized that that's solved and you had to come back or navigate differently? Any of you? Pinaki?
Yeah, I think it's very difficult. Like it is always better, like when you find a problem, to before start you do the literature survey, so that you know that what's the state of that system, and like how you have to proceed and what kind of progress you have to make. If you start and then you do literature survey, then you have to step back and like think differently, like so that's not ideal. So as per my suggestion, it's always better if you do the literature survey. And also if as you progress also, you should also keep on doing the literature survey, as Saran mentioned, like on the process also, sometimes some publications comes which actually does what actually you are doing. So that's also you need to keep track. So it's a for pure research, I think literature survey is the one of the important aspects. So you need to do upfront and also continuously you need to do.
Abhinav, you want to add anything?
Yes. So in addition to that, so from my personal experience during my PhD days, right, I invested an initial whole 1 year into the literature survey, and that helped me later on. So when actually I was doing the research component in the PhD part, things were much more seamless because I was much more aware of the more recent works done in that domain. But I had to invest a lot of time in the initial, literature survey. So, and the important part is, if you're doing a thorough research or thorough effort is being put into your, literature survey, a lot of research based questions like novelty, impact, they're automatically answered as an outcome from your literature survey. So it is very important that you invest time and energy in this part and not rush through. And as mentioned by Swarun and Pinaki, there's a continuous process. It is not that you will read 40 papers and job done. You can graduate with a PhD 2-3 years down the line. Whatever you have read at this point of time as state of the art is actually archival in 3 years. At least in com theory, in our areas, things are moving so fast that if you're not updating yourself, it becomes really difficult when you actually go and try to publish it towards the later half of your PhD program. Things can be
Particularly
difficult.
if the topic has been going on for a while, then it's even more important to go into details to see, what exists and what doesn't exist. But even for new topics, maybe not exactly on that particular topic, but what else have been the mechanism to solve similar problems could also be studied, right?
Yes.
That's also part of literature survey. It's not just on that same topic, but around that, right? Anything, Srija, want to add?
Yes, sir. So whenever literature review comes, for me, the metaphor comes into mind, standing on the shoulder of giants. Something Google Scholar also says, before also people said, even Newton and all. But it's really important, which clearly emphasize. So I do believe strongly in that, because one of the objective I changed later, because later point I realized it is already done. But luckily it was an objective, not the whole domain. So from that day, I realized, and even I do remember just before submitting my thesis, I was sitting and doing literature review the day before also. I was looking at it and then I added one, telling this is a recent trend right now coming. So really important, literature review, really important. It will save your time later in all the aspects, whether it is with respect to the novelty you are talking in, what is the contribution others had done, and how you are going to differentiate your contribution with respect to what others has done. So this particular point is really important to emphasize what is your contribution. So this.
So I would like to continue with you just to say that one is the literature survey that we discussed, but also I think these days many problems, we take methods from another place or we combine two fields. It becomes interdisciplinary. I mean, when I was doing PhD, it is like, all the speech compression, distortion measures, they were there, but we wanted to say from time domain to frequency spectrum. We went to neural space, and I borrowed the cochlea model from, Apple that time. And we built some information theoretic approach for discrimination information. The hidden Markov method was there for speech recognition, but not for this purpose. We brought in. So I wanted to ask you this question of, how do you see the cross-disciplinary aspect? Is it growing? Is it, what's your reaction to that?
I would say that's the trend now, interdisciplinary aspect, because there comes novelty first point. When whatever you have, you are done extensive research on the existing problem, and then again you're looking at, maybe we'll feel the innovation what we are looking at, is that enough or not? But when interdisciplinary comes, definitely there is one more important point. Literature review is more, because you have to study that domain and this domain as well. So I do remember, like, my literature review was never ending. And that's the reason I said even before the day I was working on this. So both domains we have to be very clear. So this is one risky part. But then when you are telling, when I said DNA computing, everybody's like, can we use DNA for cryptography? So this question, even during my thesis defense, it was there. Who are attending for the first time was there, like few of the PhD scholars, students, degree students, is it possible? So this is one question you have to face every time. So extensive literature review really plays significant role. Interdisciplinary is important, but then having literature review is also really important with respect to both domains. But when you are applying this, feasibility is something really you have to look in. There is a risk factor also, because most of the topic when we go for interdisciplinary, and I say security with DNA computing, there will be so many questions. Is it feasible? And analysis part was not at all there when I was looking at most of the research paper. So there are risk factors involved. But if you are really okay to go ahead with the risk factor involved and you're going, later it will give you better results with respect to interdisciplinary is what I felt. This is my own perspective from my own.
Great. So Swarun, I mean, some of these problems are naturally cross-disciplinary. Whole space of robotics are opening up that way, but some are apparently not so cross-disciplinary. But maybe you can still bring in methods from others. Somebody is doing game theory and bringing it in. So your tips.
I think interdisciplinary. I think it's already mentioned by Shrija, right? That interdisciplinary is a very easy way to bring in novelty and bring in creativity to research. There's a good reason for that. It's unfortunate, but it's true that most of our education systems around the world are siloed, right? We get a PhD in field X, right? We don't get PhD across. There's no way to get a PhD in DNA computing, right? It's two completely different. You either have to choose the computer science department or biology or some place, right? It's just hard. And even a particular field like wireless that I work on is interdisciplinary. It's at the boundary of EE and CS. There is no undergraduate program that can give you the right balance of everything that you need to know that straddles physics, electrical engineering, computer science. It's really hard to get the right breadth. And on top of that, I mean, I still have found that there are things that I needed to learn, like material science, for example, for some of the tattoo work, which is beyond. So I think the right solution, I think that I found is collaborators, right? There's no way you can learn every single field. It's just impossible. So if you can bring together somebody who knows human-computer interfaces, somebody who knows material science, and somebody who knows wireless, I think it's me, right? Together in a room and have them discuss and sanity check, that makes production of these sorts of interdisciplinary work so much faster and so much more rewarding, and ensures you against novelty and all that, right? And also provides new inputs and new perspectives. And I think this is the model that seems to work across the board, at least when you're starting the very first time on an interdisciplinary project. Consider talking to a colleague in a different building. You might find that conversation is much more rewarding than what you have with your advisor. Yeah.
So your PhD is your topic and probably you have to manage your way, but as you start growing new programs, you should find collaborators from other disciplines and they know the subject, and everybody would learn a little bit of the boundary interface part of it, but you can rely on the expertise of the others. So that's a great point. Pinaki, you are in, all others are in the universities, so you are in industry.
Yes.
So what do you see? I mean, you have seen a little bit of, your postdoc period and research in the academics versus industry. Do you see difference? What are the kind of differences? Could you highlight?
Yeah, I think there are certain difference here. Like in academy, mostly we do at least during her PhD and postdoc time, we focus 100% of time to our research, doing research survey or then doing the research implementation. So, but in industry, it's little different. Some things are little challenging because when you are in the academia, then the licensing issues are very less. Whenever we get some open data sets or open source code to use those, it's very easy there. In university, everything has it's open, and then even if you want to get some protected data, you just have to mail and sign some agreement and you will get those data. But in commercial industries, it's very hard. You can't use those data due to some licensing issue, even the code. So those are the, I think, most difficult challenge here. Even though those are available to acquire those or to get those data, there are strict process in the industry. So you have to go to the process, and that might sometimes delay the progress. So that's one of the challenge. And other than that, like even if you want to do pure research, there are I think lot of process related tasks you have to do. You cannot like overlay those things, like how much like the whatever the code you develop or implement, what are the code quality, or to be into the commercialization system. So those we actually don't care when we used to create system for publication, because then the code quality and the competency of the software does not matter. They are actually matter like to prove your solution, to get the accuracy or the evaluation process. Those are matter. And so this is one aspect. And another aspect, when you work on the industry, I think the first priority for us is to commercialize, right? And for that, actually, especially the industry like Samsung, the accuracy level has to be nearly 100%. So if you choose some very difficult problem where the state of that system is accuracy is less than 80%, or let's say 50%, like question answering system, it's very difficult to attempt those, because you know that even though you beat the state of that system, it's very difficult to get it to the commercialization. So that's one of the challenge. So you have to very careful to choose your problem and choose your solution. And especially for Samsung also, one of the problem is we currently target most of the on-device solution. So on-device there is another aspect, like you have to take care everything, like how much RAM uses, how much battery uses, everything. So those aspects every time we have to take care, which we actually don't care in the academia.
So you talked about the system limitations that are there practically that have to be kept in mind. And you talked about tools and licenses that you cannot just use it freely. You have to be cognizant of that, either pay licensing fee or avoid that and solve it. And since it is going to end customer, they would choose a accuracy level. It may not be always 100%, but up to this is absolutely needed for me to have a meaning out of it. So if it is below, please go back and work in your lab, but don't bring it to the product, right? That's what you're trying to say. Thank you. Thank you. Abhinav, so I'll ask you a different question, being from the academia. You know, the professors always have this pressure of, publications and for your growth and everything. So how does, in general, and you see that, and how do you target for which journal to do, when to publish? Is it a burden? Is it a fun? Open question. Comment, please. You, and then I'll come to Swarun on this.
Sure. So I think basically our aim for any research work is when we are doing it with our students, right, graduate students or otherwise, the idea is when we are comfortable with the work done to the extent that we believe it is publishable, we recommend please go ahead and publish. Please start writing a paper. Right now, that is based on experience. It is very subjective to decide that when the work is ready for publication, and it varies from for the same student. It may vary from one work to another, right? Because we are just, in some sense, trying to perceive the quality of the work in terms of the impact, in terms of the novelty ourselves first, and then when we are convinced, we say, okay, now let's try to write it and share it with the bigger community, take some feedback. So that is as far as when to publish. Where to publish, my recommendation is always aim for the best avenue available in your area. Worst case, it will get rejected, but you still get reviews. So the idea is we always aim for the best. And then if that doesn't work out, we implement so rejection or the review process is actually very important as a learning process for any graduate student. Because unless your paper is rejected, you will never learn what is not acceptable research. So that part is also important as a learning curve, and that really helps the student, to figure out, okay, these are some aspects which are probably missing in my research or which I need to improve upon. But of course, reviewers are also human. Sometimes good works also get rejected, but that's okay. That's another discussion altogether. So my recommendation is please talk to your guide, please talk to your PhD thesis supervisor and take their advice. If they're telling you the work is not ready, most probably it is not. And in my personal experience, a lot of time it has happened, especially in the review cycles, maybe not during the initial submission, but during the review cycles, I have told my students, you are doing this, but probably the reviewer will not like it for XYZ reason. And sometimes bang on the same comment comes from the reviewer side. So that really helps the student also appreciate that, no, okay, maybe I should listen to my supervisor, So yes.
And then depending on students, maybe you will suggest that since he's in rush or cannot maybe do to the highest level, so maybe you suggest some journals or conferences to participate accordingly, or you push them to say, let's keep doing, this is a good space, and right? I mean,
yes. So actually, it's not just the research, right? There are two human beings involved. So there is always this discussion happening where we are trying to push them for quality, and they're trying, for some of the students who are in rush, they're trying to push for timelines, and then we have to find some middle path. That always happens for certain set of students. But see, as a prospective PhD supervisor, our aim is not to stretch the PhD for 4 years or 5 years, right? Our aim is not to make sure it's good work. It should be impactful. It should be good work. Now, if the student is good, they say they're sometimes able to finish it in 3 years. For some students, it may take some more time. Everybody has their own learning curve. And it is not just doing the research part, right? Publication in itself is a different ballgame. Because the review cycle process, only once you go through it, you start appreciating how to write, what to include, how to motivate the problem, how to write the introduction. So as I was earlier mentioned by Dr. Shija also, right, that the writing in itself is an art, and it takes a while. It takes at least 1 or 2 papers before you learn it. Yes.
Sure. Good point. So Swarun, your take on this, and particularly you are working with so many graduate students. So what do you see?
So I think I almost echo everything that all the great points that Abhinav made. I think the only thing I would add is emphasize quality over quantity. It's important, even if you have this one paper at the #1 conference or journal in your field, that is more valuable than a ton of them in low quality venues. So aim high, at least try, give it a shot. And I think if you have the discipline to aim high from early on, then that just sticks with you, and you have a greater chance of success later on. If you want to talk about when to publish and what is the right time to publish, that is a combination of various things. I think the easiest way that you will yourself develop the instinct for it is put yourself in the shoes of a reviewer, look at your own paper critically. Would you accept it? Are you happy with it? And this is very hard, right? Because it's hard to divorce yourself from all the emotion and effort that you put in.
Sure.
Right? If you have that discipline, right, and you're able to objectively think about your paper, there will always be some weaknesses. There's no perfect paper, but would you accept it? And the way you get that training is by reading a lot of other papers in high quality venues, having an understanding of, they're also not perfect, having an understanding of what that bar is. And if you're not able to catch that immediately, if you're inexperienced, using your advisor, using your colleagues to sort of get some feedback too. Sometimes they see things that you don't see, right? And that's how you gauge when exactly to publish. Is your work ready? But aim high. Try to try to shoot for the moon, right? In whatever field you're in, and it's okay if you fall short.
So quality first, and try to target for that, and then, as Abhinav said, at the end to human beings, and we'll settle somewhere depending on many factors, right? Pinaki, I mean, as you mentor also other young joinees, freshers, researchers, what do you see there?
Yeah, obviously, like quality has to be prioritized over the quantity, and for the freshers, we also try to motivate to publish paper, but being in the industry, our process is to to patent first your idea and then we publish. So that's also one of the aspect. Like for the process, actually, it's get reviewed. The quality has been reviewed because we have a very good IP team led by Dr. Alok, and they actually reviewed your idea and the innovation, and then you file the patent and then you publish. So by that process, actually, it's get verified. And also, like for if you are, because the aim for in industry is the commercialization, the quality and the accuracy of the solution anyway will be verified for the commercialization. So definitely, if you aim for the quality, then you will reach in every stage, like be it patent, be it publication. End of the days, like quantity will not quantify your contribution unless it is like get accepted by others, right? Even it's like in publication, when we do publication, we always count how good the publication is based on the citation. If your publication is not the good quality of work, then no one will cite. So same as like patent also. If your patent is not very good idea, then it will not be implemented and commercialized. It will be just fall into the patent.
So in the
why,
industry, yeah. So the key
yeah.
point is, you know, you are here for commercialized products and user satisfactions, and then patent and then paper in that particular order. And you wanted to say that what goes in publications in university, maybe equivalently we do patents, and that's more important. Srija, I wanted to ask one question a little bit related, and you can respond to this question also, but also not all institutes are the research institute completely, and some are more, some are less. And from your institute experience or your earlier experience, could you say that you wanted to pursue things, but is it difficult? Or if you can nurture them well, it's possible to bring things out of it and then still get papers. What's your experience on that?
As a student, like I would say from both perspectives, because I did complete my PhD from there. So right now, even I'm guiding. There is a difference, even though it is few years, actually there's a huge growth with respect to research perspective from institution level. Now they are giving more emphasis on research, because that's where actually the social contribution also is something which is associated with research. So now more emphasis is on research. In that way, if I consider right now, the scholars are coming in is actually facing like a lot of challenges, because quality comes in here. When it is compared to 5 years back, what we had, or right now what we are looking in, there are so many layers which has come in. Everywhere there are one or two layers they have to go through. Say it is for just for a title submission or a proposal presentation. Now 2 to 3 layers are there. So everywhere there is a research advisory committee. So they have to give a draft before them, get the review. The review will be critical. They have to include, incorporate, come back, then go for the next review. Then only we are going for the first level of draft presentation to be one of the examples, just to say. Then we go for department level, then we go for Center for Research level. So in that aspect, actually the process is intense now, but aim is at definitely quality. So publication, when we go for that, if we are looking at this level, it will take some time. This is one of the things, it will take some time, but when it goes in, definitely it goes as a good work. So challenges are there,
Great.
but it helps.
Thank you. So as we are coming closer to our time, just one last round that we will go around. We'll start with Abhinav and, Srija, Pinaki, and we'll conclude with Dr. Swarun. Your advice or messages to sum it up. We said how to create a research mindset, and we started with the question of what are the attributes, and it's hard to do that, but you have talked about various dimensions, traversals of your own doctoral thesis topic to PhD being a very long drawn process. How do you keep somebody motivated? The literature survey importance that is there. Did you need to change directions, interdisciplinary approach, when to publish, patent, industry setup, academia? I think we covered quite a good number of topics in different forms. So we'll just open it. And if you have to give messages to people that are doing, and not just the people here, but our videos are quite widely viewed by, people. I've seen 5,000, 10,000 views of our past sessions. So don't count the 50 plus people that are here, but also keeping that in mind, if younger people, if you want to give a message, what would be your advice, messages to young people, how to create a research mindset? And when it comes to Swarun, I want him to also say, because I've seen that he has been there in CMU and all those research, but also when I saw him knowing the fast tag here or the passport coming, so he's quite thoroughly knowing about India. So you could take any stand, and if you can give some nice messages, how can they grow this mindset? So Avinav, over to you.
Sure. So first thing I would recommend is that please ask yourself the question, if you're planning to start any research-based program, why is it that you want to pursue it? If you can answer this question honestly, then the rest of it is a cakewalk. Because if you have an honest answer, that answer motivates you for 4 years, 5 years throughout your PhD program. But if it is just because it's a lucrative option at this point of time, and probably it's going to land up you a good job in academia or industry, then that is where real problem starts coming into picture. Because if you're not joining the program because you have a passion, as mentioned earlier by Swarun, or if you're not enjoying what you're doing, it will create issues in all aspects of your research work. So please try to answer that question first. Why is it that you want to pursue a research program in this particular domain? And once you have an answer to that, parallelly, please always try to have a support network, especially for PhD students. It's a long journey, 4 years, 5 years of your life. It's a big investment. Do keep your family, friends, lab mates all close by. They really help. There are always ups and downs for everybody. Nobody is a born researcher. Everybody has to face rejection at some point in their research work. It's part and parcel of any area, not just research. So please have your support system. It will help, and keep it fun, as mentioned earlier by Shija and Pinaki, and enjoy the process. It's fun, and the learning is not just from the publication getting accepted. The learning comes from various aspects, starting from your interaction with your guide. If you're doing interdisciplinary research, interaction with multiple guides, managing multiple guides together, so all that is a learning process, and that helps you going forward, no matter whether you choose academia or industry. So please think it through. And if you really think you will enjoy it, and you have some exposure to it, maybe through a BTech project, or maybe through an MTech thesis, 1-year MTech thesis, use that experience to make a call, and hopefully it will be a pleasant and fun experience for you too. Yes.
Avinav, thank you. Thank you. I remember, Professor Peter Cable was my supervisor in McGill. He asked me first day, how would you like to be supervised? I says, minimum supervision is the best supervision. So I will come to you when I need, and I know exactly where people can do it, but not everybody. And that's why he asked that question. Some wants it to be very closely supervised, some wants differently. So it's a choice, because you need to enjoy, and it has to be your style of it, right? Srija?
So to start with, I'll say passion is the key, because self-motivation comes in. So that becomes easier. So while selecting the topic, passion is the key. I would say 3 more P's: patience, persistence, and perseverance. Really important. You talk about visualization, data visualization, and all those things, right? So similarly, I would say visualize your PhD. The day you will stand on the podium and receive your doctoral degree makes you everything fall in place. This is something which I did. It's tricky, might work for, might not, but it worked for me. This is something which I did. That really motivates you. So there comes all the self-motivation required. So I think if these things you are able to cope up with, you are able to do this, then definitely. And one last point, it's your PhD. This is something which we have always to say, it's my PhD and I'm not going to give up. This is something we have to realize and remember every time, whether I have guide, I have all the supporting system, I should always remember it's my PhD. So whatever it comes, I'm not going to give it. This is something we have to remind ourselves.
Great, not giving up, and start with end in mind. You receiving the PhD degree,
exactly.
And so enjoy that moment and do all the hard work that is needed. Thank you. Thank you. Pinaki?
Yeah, actually, Srija and Avinav both covered most of the things. So most important, before starting the self-motivation, really all the students needs to ask themselves that why they want to do this, because there are a lot of opportunity. It's not that you have to do on the research. There are other opportunities. So why you want to do research, and then down the line, how you want to see yourself. So that things needs to be cleared in the mind. Otherwise, just to sake of doing higher studies or just to sake of like getting job, it's not good practice, because down the line you will definitely get demotivated because it's a long process, and then it will create a problem, like either you will lose your time or you lose your energy, so everything. So that's why self-motivation and clarity in the mind is the main thing. And then obviously, if you, once you decide, patience is the most important thing, because it's a long journey. You have to keep motivated and hungry for the outcome. Also, like don't get demotivated if you get one rejection or any like bad incidents, whether with your supervisor or with your work. So don't get demotivated. So that's the most.
Find
So
out
whatever
early
you
and
start,
have
you
the,
need to finish. Yeah. So
have the
that's
intrinsic
the major
motivations
thing.
and keep going.
Correct.
Thank you. Swarun, to close.
I'd say first aim high. I think at the end of the day, I'm sure every PhD is sort of a world expert in some field that's around their thesis, right? So try and recognize the amount of depth and knowledge that you need to build to really build your thesis, and work on something you're really excited about. Third, I think it was mentioned a lot, stay motivated, have a network, have a support system. I know it's a year of COVID-19. We all have, our lives have been shaken up, doing systems research, tinkering with hardware at home or outdoors in socially distanced ways is not fun. So the only thing that can help you stay motivated is your internal excitement for what you're doing and the support system and the network that you have around you. And know that everybody else in the world is also suffers through PhD midlife crises and questioning yourself, and should I do a PhD? Everyone, including myself, have gone through that phase. So don't think you're alone. Everyone has experienced ups and downs through PhD and through your research life. So don't be disheartened. Use your network. And finally, I'd say about India, since that's something I want to emphasize, right? India is at a crucial point where we are at the cusp of moving from sort of developing towards a developed economy. I'm sure in our generation we are going to make that change, and we can make that change. And who's going to lead that change? Researchers, because the only way India can grow is by having leadership and creating new industries and being the leaders of these new industries. And the only way to lead new industries is research. So I'm sure some people who are in this call, some people who are listening to me at some point are going to be leaders in the world, creating new trillion-dollar companies. And India has opportunities. It has a young population. There is a lot of, we can leapfrog from 0G to 5G, right? In a matter of years. That's something we can do here. We don't have to deal with legacy frameworks. We can scale in a flash with the right support system and with the right we have access to labor, we have access to resources. So it just requires the research mindset as well as enough motivated young people to work on these problems. And I think we can do it. We can do it in this generation. And researchers like you and I, right, are going to be part of that in some way or the other. So if you believe that honestly, and if enough people believe that, I think we can do it. So have the responsibility and the thought in your heart that you could be the change that we can see that we all want to see in the country.
Sure. Thank you. I started by saying, the long-term growth, business growth, even quite a lot depends on this R part of it along with the D, and you are reaffirming. So great to have all of you in the panel. Swarun, again, thank you for making the time to have the presentations and also agreeing to be part of this panel. We wanted to utilize your presence to steer these discussions. So thank you again, all the panelists, and it has been my pleasure. Over to Subhash.
Thank you, Dr. Alok, and all the panelists. I can only clap to say amazing session, absolutely amazing session. There are a lot of appreciations that came in on the chat, and till the end, a lot of people stayed back. So thank you all the audience. And if you have any follow-up question, please do reach out to us. We will make sure that all panelists are available to respond to your queries. Now, before we close the session, I would request and call Dr. Rajiv to give a vote of thanks. Rajiv, over to you.
Thank you, Subhash. It's been a wonderful evening in India. We've really enjoyed the session, the extended session, the talk by Dr. Swarun Kumar, the wonderful panel discussion. Let me start by thanking all let me start last in LIFO way. So the panel discussion. Thanks to Aloknath for being a great moderator. I know Alok for many I think decades now, and I know that whatever Alok does is with great passion and intensity. So Alok, it was indeed a wonderful panel discussion. I think they were amazing. So here's a couple of key takeaways from the panel discussion. But before I come to that, I'd like to thank the distinguished panelists, Srija, Pinaki Bhaskar, Abhinav Kumar, good old friend, of course, Swarun Kumar, know him for some time now. Very diverse panel. So, it was by design that the panel was very diverse from not only India, but, India, US, and I think we'll continue that in course of time. Great questions, very critical. In fact, Alok, thanks to you for suggesting. I was talking to Subhash and Prashant earlier, and the way we converged at this topic, a very critical topic, as Swarun also pointed out for India today, to have a communication research, a research mindset, basically. And I think that's something that is extremely critical for all, particularly for India today, as we leap forward, into as the technology changes exponentially. So I think it's wonderful. Great views from all the panelists, very diverse views, right from a mindset to, collaborative aspects. And I think so one of the key takeaways is collaboration. And I think it's so crucial to collaborate with the right people all over the globe, going outside your own ecosystem, the comfort zone. Then there were thoughts on, what does it take to become a good researcher? Of course, passion is critical. It reminded me of our days in PhD in ISC Bangalore when we were all under tremendous pressure. But I think all the points that you mentioned, they come so well. And I'm sure the panelists, our delegates, the registrants, the participants really enjoyed the panel discussion. Just to share with all, we had about 100 registrants today. I was just talking to Subhash. We had 100 plus, which is a wonderful number considering it's evening India time. We also had some great researchers. For those who may not realize, or probably you were busy, Gerard Berry was there from France. Gerard Berry is a global guru in verification and validation. He's a global guru, and he was there. I think he's still there. So we had some great, researchers participating and listening to you very carefully in the panel, as well as Swarun's talk. So thanks again to all the panelists and to Dr. Aloknath for moderating a wonderful panel. Of course, Swarun Kumar. Now let me come to Dr. Swarun Kumar's talk. Every time I hear Swarun, whether it's ComsNets or in other places or read his papers, I think they're very insightful. And one of the key, things that you will see about Swarun is he focuses on building very real systems that theory, of course, is important, but he builds the systems, learns from there, and then, applies theory. So I think it's a very interesting, research mindset or methodology. And building a system is not easy at all, as we've seen not only in his talk today, but many other work that he's done earlier. I remember going through your paper on monitoring the wearing of tires, right? Using the various technologies, the wear and tear of tires. And I think it was such a critical technology for OEMs today that, Swarun, I'm sure you can become a whiz kid with all the OEM, whether General Motors or Toyota, if you just sell the technology. So thanks, Swarun, for your wonderful talk, extremely insightful, very informative. I know that there'll be many questions. I did have many questions too, but I'm going to send that offline over email to Swarun. There were great questions from our audience. I'm sure there'll be many more questions going forward for not only Swarun, but our other panel members. So at this point in time, again, let me thank sincerely on behalf of IEEE ComSoc Bangalore chapter, the Delhi chapter, the ACM India Council, and the Indian National Academy of Engineering for thanking all of you. It's been a great evening, learning throughout, and I think we're going to continue such discussions, talks and panel discussions in course of time. So I'm sure, Alok, you raised the bar, and we're going to continue such sessions over the next few months. I'd also like to thank Chengappa for all the hard work that he's put in behind the scenes. So he's the back end of this entire thing. So he's really put in a lot of work to enable not only the platform, but to ensure that it's up and running and everything is tested nicely. So thanks, Chengappa, for all your hard work. It's been wonderful. With that, I'm going to hand over to Aloknath, Day, and Subhash. But thanks to all of you, and have a wonderful day. Thanks.
Thank you.
Thank you,
Thank you
Rajiv.
all. Thank you.
Thank you.
Thank you.
Thank you.
Okay, with that.